Let's graph the linear equation for y equals 1/2 x plus 1. And we can do it two ways. One, we can put values in for x here, figure out the value for y, and then we can plot those on our graph here. Then next, we can check our work with the slope-intercept formula. So let's plot some values and put them on our graph. Let's say if x is 1, 1/2 times 1, that's 1/2. So 1/2 plus 1 and 1/2, that gives us a y value of 1 and 1/2. And we want to choose values that should probably show up on our graph here, not out here on the edges. So how about 0? If x is 0, 1/2 times 0, that's just 0 plus 1. That gives us 1 and -1. 1/2 times -1, that's a -1/2 plus 1. We end up with just 1/2. So these are all points that will be on this line here, y equals 1/2 plus 1. So let's graph them. We have x is 1, y is 1.5. So here's x is 1 and y is 1.5 right there. If x is 0, y is 1. So 0 for x, y is 1. And then the last one, we have -1x, positive 1/2 y. So we go negative and positive 1/2. And you can see we have this line here. We could have used 2 points, but with 3, if we make a mistake, we'll be able to catch our error. Let's put a line through it. Let's put arrows here to show that it goes to infinity. Now we can check our work with slope-intercept formula. So we have y equals mx plus b. B's the y-intercept, that's 1. So the line should intercept the y-axis at 1, and we go down and right there, 1. So we're good with that. For the slope, we consider this to be rise over run. So we'll come over to our y-intercept, we'll rise 1 and go over 2. That's on our line. From there, we can rise 1, go over 1, 2, and again, rise 1, go over 1, 2, and all those points are on the line. Likewise, we could go down 1 and over 2, and from there go down 1 and over 2, and those are also on our line. So this is the correct equation for y equals 1/2 x plus 1. If we put other values in for x here and got the value for y, those would also be on this line. This is Dr. B with the linear equation, graphing the linear equation y equals 1/2 x plus 1. Thanks for watching.